Hello students, I hope you have seen the video in your third period and I'm quite confident that you have understood what is factorization and what is a factor is all about, but still I'm going to give some introduction if in case some of you have not understood what is factors, because to understand the factorization you need to understand what is a factor. Now factor is what? Suppose let's take a number 12. Fine. Now you have to see some pairs of numbers which you multiply and get the product as 12. Suppose the first pair would be 1 into 12. That is, you will get 12, isn't it? So if you multiply 1 and 12, you are getting the product as 12. So when you divide 12 with 1, you will get no remainder. Similarly, if you divide 12 with this 12, you will also not get any remainder, but the remainder will be 0. Similarly, there are another pair, that is 2 into 6, which will again result to 12 only. So these are the two numbers. When you multiply, you get again 12. So what does it mean? It means that when you divide this 12 by 2, again the remainder would be 0. Similarly, when you divide this 12 with 6, again you will get the remainder as 0. So there's another pair, that is 3 into 4 equals to 12. Okay, now what does it mean? It means that when you multiply this 3 and 4, we are getting the product as 12. And what is another meaning of this? That is, when you divide this 12 with 3, you will get the remainder as 0. And similarly, when you divide this 12 with 4, you will again get the remainder as 0. So what is the factor then? So factor is what? So factor is a number. So factor is a number which exactly divides the given number. Fine. Now what is the given number in this case? The given number is 12. Now these are all the numbers which divides this given number, and when you divide you will get the remainder as 0. So you can write factors of 12 are 1, 2, 3, 4, 6 and 12. Understood? Now when you write this number, suppose when you write 12 in the form of a prime number, okay, so there is some prime numbers, okay, so when you multiply those numbers, suppose if I take another example as suppose 30, okay, now 30 can be written as 2 into 15. If you further divide this 15, then how can you write 2 into 3 into 5, isn't it? So 15 can be written as 3 into 5. So you see that 30 is written as a product of all the prime numbers, isn't it? So a number written as a product of prime number is said to be the prime factor form. Fine. So what is a prime factor? So prime factor form of 30 would be what? So 30 prime factor form would be 2 into 3 into 5. Okay. Similarly, what is the prime factor of 70? So if you divide 70, so you must have done a prime factorization, that is 70, you see, 2, 35, 5 into 7. So what is the prime factor form of 70? That is 2 into 5 into 7. Okay. So the prime factor form is a form where you will find that all the numbers are prime factors. Okay. Similarly, we can express the algebraic expression also as a prime product of their factors also. Okay. So today we'll understand how to find the prime factor form of an algebraic expression. Okay, students. Now let us take an example. Suppose 5xy. So this is an algebraic expression. So this is an algebraic expression, isn't it? Now how to write this? Now to express it in the product of factors. Okay, how to write this? So how to express this in the product of factors? So 5xy can be written as 5 into x into y. Okay, so 5x and y are all prime factors of 5xy. Okay, the 5x and y are all the prime factors of 5xy. So in algebraic expression we use the word, you have to understand that this sentence is very very important, students. In algebraic expression we use the word irreducible in place of prime. Okay, always remember. So when we say that 5 into x into y is irreducible form of 5xy, instead of saying it is a prime factor form, fine, it is a prime factor, so we'll say now it is a reducible form. So you will write that 5 into x into y is the irreducible form of 5xy. So this is the word that we use in place of prime. Okay, always remember in algebraic expression especially. Okay, but you have to understand that we cannot say that 5 into xy, that is 5 into xy is a reducible form. So 5 into xy is not a reducible form, irreducible form. Why? As because xy can be again splitted up as x into y. So we cannot say that 5 into xy is a reducible. So it is, this form is called a, it's not a irreducible form. Fine. So 5 into xy is not an irreducible form of 5xy. Okay, and why? As because this xy can be further expressed as the product of x into y. So the complete expression, the complete expression of any algebraic form is called a irreducible form. Okay, so let us take another example, as suppose 3x plus 2. Okay, now this expression is carrying 3x and then again bracket is starting x plus 2. So what is the sign between these two? So there is one multiplication sign is there. So it can be written as a product of factors as, so 3 into x plus 2. See, observe carefully. In between 3 and x there is a multiplication sign. In between x and this bracket there is a multiplication sign. So how I have expressed this algebraic form as, so this particular expression can be written as a product of the factors as, this is one factor, this is another factor, this is a third factor. These are the three factors. Okay, so this is in the form of irreducible form of this term. Okay, so you can write that 3x plus 2 can be written in the form of this. So this is a irreducible form of this term. Now let us take another example, that is 10x plus 2 and y plus 3. Now you see that this is not in the irreducible form. And why? Because you see you can split this 10 into the further expression, isn't it? How to write 10? So if you do the prime factorization of 10, 2, 5, 5, 1. So in place of 10 we can write the product of 2 and 5. So in place of 10 what we will write? 2 into 5 into x. Now again, what is the sign between x and between this bracket? That is into. Now I will write x plus 2. What is the sign between these two bracket? Again you give into. Okay, y plus 3. Okay, so the expression 10x, x plus 2 and y plus 3 can be expressed in the irreducible form of this. I hope you have understood how to express the algebraic form in the irreducible form. Okay, always you have to change it in the irreducible form where all the prime factors should be there. Okay, so how many terms are there? See how many expressions? 1, 2, 3, 4 and 5. These are all the factors, students. How many factors? 1, 2, 3, 4, 5. 5 factors are there. Okay. Now, what is factorization? Now, this is a very important thing that you have to understand. What is factorization? So factorization is what? So factorization is, we can say that when we factorize any algebraic expression, because in this particular chapter we'll concentrate on algebraic expressions, okay, not only on numbers but algebraic expression. So when we factorize any algebraic expression, we write it as a product of factors. Okay, the first thing that you have to know about factorization is we have to get the factors, and when you express all those factors in the form of product, fine, when you express all those factors in the form of product, then that is called factorization. Suppose if I say 12, so 12 can be expressed in the form of factors. What we did as 3 and 4, sorry, 3 and 4 are the factors of 12, but when you express these factors in the form of product, then it is a factorization. Fine, so this method is called factorization, but individually these are the factors. So this is called factorization. Okay, so it's a similar things we'll do with the algebraic expression also. Suppose if I say 3xy, so what are the factors of 3xy? 3x and y. But when we express all the factors in the form of product, and we say that, okay, in the form of multiplication, fine, and we get this product as 3xy, so this expression is called an factorization. Okay, so what I've said that when we factorize any algebraic expression, we write it as a product of factors. So product of factors, isn't it? So these factors may be numbers also. These factors could be variables also. Okay, so it could be anything. So we'll learn how to express in the form of the product of factors. So suppose I'm giving some of the example as 5 x square y. So how to write this as a factorization process? So 5 into x into x into y. So this is how we write the factors in the form of product form, and it will give you as 5x square y. Okay, so there are many terms which are already in the factor form. That is, this one is the example, this one is the example, and you can take another example as 2x y plus 2. These are all in the factor form only because it is already expressed in the form of product. But there are some numbers, suppose 2x plus 4, when you see that plus and minus is coming, so these expressions is not obvious, but their factors are. So but just by looking to this particular expression, we cannot say what are the factors. So for this, to get the factor of this particular expression, that is 2x plus 4, or suppose 3x plus 3y, or you can say 5x minus 6. So these are some of the forms where you are not sure of the factors. So to convert them into the factor form, or to get the factor of this all expressions, we need to develop some systematic method so that we can factorize this expression. And this systematic method we'll learn as we'll slowly and gradually approach with this chapter. Okay, so the first thing we'll learn about this chapter is common factors, but not today. We'll only today, as I've already given you one video, I hope everyone has seen, and in this sessions I have again revised you what is the factor and factorization, what is the irreducible form. So today only you concentrate on the introduction part. From tomorrow onwards I will discuss on the topic that is common factor. Okay, so tomorrow we'll discuss on this particular topic, that is common factor, and how to get the common factor of different algebraic expression. Okay students, thank you and take care, and God bless.